Welcome to Spring LIB.
Hello everyone, today we're looking at a problem that involves a mechanical winch. This winch is consisted of a drive gear, a driven gear, and connected to that driven gear is going to be a winding drum. The winch itself is going to be raising a load, so we will put our rope coming off the winch connected to a load. And we're going to name our components here. So we have drive gear A, we have driven gear B, and we have our winding drum C. B on the outside, winding drum C. What are our knowns? We know the radius of our three components. Radius of A equals 3 inches. Radius of B equals 18 inches. And radius of C equals 15 inches. We also know what our rotation rate for A is. A is going to accelerate initially from 0 to 120 RPM, and it's going to take A 5 seconds to reach that speed. After that, it's going to continue at a constant rate of 120 RPMs. So what are we trying to solve? We want to know how many rotations does A turn for A to lift load 20 feet, and how long in seconds. So let's get after it. So the first thing we need to solve, if we want to know how far a winch is, how many times a winch needs to turn to move something a certain distance, we need to know the circumference of the winch of C, which equals pi times the diameter, which in turn equals pi times 30 inches. But since we're moving this 20 feet, let's convert everything to feet right away. So we're going to divide that 30 inches divided by 12, and we're going to get 7.85 feet circumference. How many rotations does C need to turn? Well, we take our 20 feet, we divide it by our circumference of 7.85 feet, and we get 2.5465 rotations. Now, that gets us to C. B is going to rotate the same as C, as they are connected in line on an axis, but we need to know how many rotations does A turn. So we have 2.5465 rotations at C, and we're going to take that times the gear ratio of gears A and B. So we take the radius of B divided by the radius of A, which equals 2.5465 times 18 over 3, and it gets us 15.28 rotations at gear A. Now we need to know how long does it take to get to 20 feet. So 0 to 120 RPM in 5 seconds. We're going to assume this takes longer than 5 seconds and take the average of that. 120 subtract 0 over 2, that is 60 RPM for the first 5 seconds. 60 RPM also equals 1 rotation per second, as there are 60 seconds in a minute. So for the first 5 seconds, we end up going 5 rotations in the first 5 seconds. Spelled rotations wrong here. Let's fix that. So we need to go 15.28 total rotations though. So how many rotations are left? 10.28 rotations remaining at 5 seconds. So now that we're at full speed at 120 RPM and we're running at a constant from there, we're going to look at that for the remainder 10.28 rotations. 128 RPM equals 2 rotations per second. 10.28 rotations divided by 2 rotations per second is going to equal 5.14 seconds. So we take our 5 seconds initially plus our 5.14 seconds, and we get 10.14 total seconds to move the load 20 feet. And that does it for this problem. Thank you.